Blaise, what's wrong?
Someone graffitied all over this desk.
I think it's washable marker.
It's graffiti.
It's math.
It's graffiti.
It's a matrix system. It's
Oh my
unsolved.
gosh, shut up, you nerd.
Blaise.
Sorry, I'm just distressed.
It's okay. Now, will you calm down and listen for just 1 second? This is matrix multiplication, and someone wants us to figure this out.
What? No way. I don't even know what a matrix is.
That's all right. See, we're supposed to figure it out together. See this? 1, 2, 3, 4. Matrices are made up of rows and columns of numbers or symbols. So since this one has 2 rows and 2 columns, this is a 2 by 2 matrix.
How are you doing that?
Doing what?
Okay. Anyways, you said this was unsolved, and we have to multiply it? How would we do that?
Okay, so to multiply matrices, 1 second. Okay, so to multiply matrices, you multiply first the numbers in the first row by the numbers in the second column. So you get 1 times 4 equals 4, plus 2 times 6 equals 12. So that equals 16. Next, we have to do the same with the second row. So that equals 36 and 43. And that's our answer.
16, 19, 36, and 43. That's what they wanted us to find? That doesn't mean anything.
I'm sure it means something.
Congratulations, you found some numbers.
You know what? You're being the worst friend ever right now. That's it. I'm leaving.
Wait! I think I got it.
What? What is it?
What if we added the numbers up?
But that's not really what you do with matrices.
But it's what you do with clues, Claire. Okay, 16 plus 19 plus 36 plus 43. What is that? 114? That's it! 114! We have to go to room 114!
Then what are we waiting for? Time is of the essence.
Is it?
This is it. 114.
There's nothing even in here. I knew this was pointless.
Hey Claire, I found your lunchbox in the cafeteria. I was looking everywhere for you.
Oh, thanks, Kate. I wonder if there's anything in here. Oh, what's that?
No way. It's a matrix.
Kate, did you do this? Kate? Kate?
This one's different from the first one though. I think it's already solved.
Let's see. Yeah, it is different, but it's not solved. It's actually a system of equations. So we do the matrix multiplication again. So we have to multiply it out again. So it's 2 times x minus 3 times y equals negative 10. And we do the same for the next. So 3x plus 4y equals 19.
I see how it's a system of equations now. Okay, so let's see. X equals 1, so y equals 4?
Yeah. So what does it mean?
I don't know.
Well, if you take the first 4 letters of the word matrix, because y equals 4, you get MATR.
And then you take off one more letter because x equals 1?
Okay, so we're left with MAT, mat.
Mat. I know, let's check under the welcome mat.
You're a genius, let's go.
This must be it.
Oh, what is it this time?
Uh-oh, the numbers look a lot bigger. And what are these brackets? Absolute value maybe? They're straight.
Oh, I don't know. I know I've seen this before, but I just can't remember where.
Hey guys, what's
Hey.
up?
Hey.
Why are you hanging out by the mat?
We're trying to solve this problem, you see, but we can't figure it out.
Oh, you silly girls. These look like absolute value signs, but actually it's a determinant. So you just go like this, and there you go.
I remember now, the determinant. Thanks for the help, Kate. Kate?
Kate?
Okay, anyways. Well, the determinant is used in solving systems of equations, which we just did above. If the answer is anything but 0, you know you have a unique solution. So it's basically just used at the start to see if you have an answer or not.
But how do you find it?
So you take the top left number times the bottom right number, in this case 2 times 50, minus the top right number times the bottom left number. So negative 11 times 1. So here we get 100 minus negative 11, so 111.
111. I don't think it would be the rooms again. What else is there?
We could add it up. 1 plus 1 plus 1 equals 3.
I don't think so.
I think we need to think outside the box.
I know. What if we think about it as 3 ones instead of 111?
Oh my god, of course. How could we have been so stupid? It's so obvious.
What's obvious?
Blaise, 1, 1, 1.
Elaborate a little further, please.
Blaise, one band, one dream, one direction.
Oh my god. Where to next?
My house.
Were the shirts really necessary?
Yes.
This is such a long shot.
No, it's not. I'm so confident about this. Take it down, but be careful with it. Careful, 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 careful.
I'm almost upset that we were right.
Don't be. This is so exciting. We're dealing with something that looks pretty similar to a matrix now, but it's actually different. It's a vector.
What? They're not matrices? How is it a vector?
Well, these are vectors in component form. The top number is the run, or the horizontal length, and the bottom number is the rise, or the vertical length. So this first vector is 1 unit to the right and 2 units up.
But it wants us to add them. That must be difficult.
No, actually, this is going to be, I think, the simplest thing we've done all day. Probably as a reward for getting so far.
So, what? Do we just add them? Add the top 2 and then add the bottom 2?
Yeah, exactly. That's exactly right.
So 1 plus 3 equals 4 and 2 plus 4 equals 6?
Yeah, that's it. That's our vector.
So what do we do with it?
Well, as vectors are true to their name, vector quantities, and they show both direction and magnitude, I think it's a map.
What? Okay, so run over rise. So 4 steps to the right and 6 steps forward?
Yeah, let's go. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. This must be it.
What is it?
It says, congratulations, you have solved the matrix mystery. Use your new math knowledge with care.
That's it? Does it say where to find our prize?
What prize?
You know, we solved the clues, we won the challenge. All we get is a measly congratulations.
Blaise, the math was the prize. Our friendship is the prize.
Okay, see you soon.
Where are you going?
I have some graffiti to clean.